Hello there, and welcome to a video presentation regarding adiweb, the latest in a series of projects that demonstrate the practical applications of the ADILOS framework and provide testable reference implementations of the parts. First off, let's do a review of the framework. ADILOS is an acronym for a digital lock system. There is a link to the ADILOS project on GitHub site at the lower left corner of the screen. Let's head over and take a look there next. Okay, here is the ADILOS GitHub page. ADILOS is a free and open source project. It simply defines a protocol. That's a definition of message types and how those messages should be exchanged. The only project asset is this white paper. Now if we scroll down in the README, ADILOS contains some subsystems, one of which is the subject of today's video. Below that, there are some links to those projects. But briefly, what is ADILOS? ADILOS enables computer device users to gain access to resources. ADILOS uses a well-known cryptographic approach to perform a public key exchange over an open channel. And so what we're doing today with adiweb is we're going to get secure access to resources where the resource is a virtual asset on the network. Now let's head over to the adiweb GitHub page. Let's just scroll down. Okay, about adiweb. adiweb is a browser client and JSON RPC over HTTP service that uses ADILOS for secure authentication and communication. adiweb has two parts. There's an agent UI and there's a gatekeeper. So if we scroll down, there's a little bit of an explanation. Gatekeeper is a service that's just sitting there listening for HTTP posts, and it's using JSON RPC. There are three different messages: get challenge and set response. This performs the authentication part, and then when you want gatekeeper to do something, there's a do message, and the do message includes encrypted and signed fields that tell the server what action to perform. And then the agent UI is an instance of a KGAgent. You could think of it as like a browser, a web browser, and the user interacts with that directly, and it serves as a bridge between the Keymaster side, which is an optical channel communication, and the network, which is obviously network digital communication. Let's take a look at the server code. Here it is in the Gatekeeper folder, gkeeper. As you can see, server is currently only one file of JavaScript. Let's take a look inside. Okay, here on line 2, one can see the service is using HTTP. The server is therefore a web server. It could be set up on the public internet, or we could operate it on the deep web as an onion. Line 6 includes an adilos JavaScript library called adilos.js. This is published as a Node.js module and makes it very easy for JavaScript programs to use the adilos protocol. And then lines 27 onward here, we create an HTTP server and we listen on our port. There it is on line 80. And you can see in this code block that if the request method isn't post, then we throw an exception, so it will ignore GET requests. And then also note on line 53, when we get the data, that we expect the data to be in JavaScript object notation format, or JSON. So that's enough code for the moment. Okay, I've just scrolled down to where we handle the message, and we can see that messages have these fields: method, params, and ID. This is basically the standard JSON RPC requirement. Stands for JSON Remote Procedure Call, where method is the procedure that you want to call and params are the parameters supplied to the message. The ID field is a unique session identifier that's established when the client completes the ADILOS challenge response handshake. And we'll show some examples of what's in the message when we get to the demo part. But for now, let's go from server to agent. So we have this agent UI, and it's a Node web app. In ADILOS terms, our agent is an instance of a KGAgent, where the K and the G mean Keymaster and Gatekeeper. And the agent's job is to be the gateway between the optical QR code communications channel expected by the Keymaster and, in this case, a network. Some people might wonder, why don't we include the agent in the Keymaster with the Keymaster? And there's a few reasons. First, we want to keep the size and complexity of the app code under control. We don't want to have to change it every time we want a Keymaster to add another service or use a different network. Second, we want to keep the app minimal, and that improves security because we limit the attack vectors by using fewer modules and external libraries and services. Thirdly, an agent has no information about the user. The server or the communications can therefore operate as a kiosk or run on a shared computer without compromising security. Fourth, Keymasters can turn off Wi-Fi and cell data service and still function normally anywhere. If we combine the agent and the Keymaster functions, then the Keymaster would need to be able to get an internet connection to the Gatekeeper, and it would therefore need to be able to use the data service, which isn't a big problem. It's just that we want to avoid the requirement to have one. Okay, so now that we've had a very brief tour of the code, the next part of this is going to be demonstrating the software at the command line. Here we are at the command line. This is the desktop. On the left-hand side here, we've got the output from the screen of the smartphone being displayed. So this is going to be our Keymaster side. In the middle, we've got the terminal, and this is going to be the agent, and this is part of the adiweb software package we've been talking about. So the agent's going to be in the middle, and the Gatekeeper is going to be here on the right. And what this is demonstrating, that now the Gatekeeper today we've got on this device, but the Gatekeeper can listen on any port, on any computer on the internet. It could be its own web server somewhere. It could be a Tor onion. We don't know. We don't know what it's doing. It just has data that we need access control and we need encryption and security for. So it could be a shopping site. It could be a renew your driver's license site. I don't know. Let's go ahead and run it. It's just going to sit there and listen, and then we're going to run our agent in the middle, and here it is in the middle of the screen. So the agent, let's pretend that it's just running in a kiosk on a computer in the mall, or maybe it's on a shared computer, it's on your home computer, or work, I don't know. It could be a browser, it could be a mission-specific program. And all it's going to do is exchange some encrypted messages with our Gatekeeper, but we could also build on top of it in the future to implement any kind of service. Maybe like an open bazaar, who knows. Anyway, So right now the agent doesn't know who I am. So let's issue an identity challenge. So what just happened here is I clicked this Make Identity Challenge button. The program sent a message off to the gatekeeper somewhere on the internet and said, please give me a challenge. And back came, this is an ADILOS challenge. And this challenge, along with a little bit of additional data, is now displayed here in this QR code for the user to respond to. So the agent doesn't know who the user is yet. And so the user comes along. I run my Simpleth, which is our latest version of a Keymaster. Enter my super secret testing pin. And I have only one key. Alright, so I'm going to identify myself to the agent, and as a result of that, the agent is going to know that my public key is this 0x031EB, etc., etc. I'm going to confirm that cryptographically. Alright, so let's go identify. And now I'm going to scan the ADILOS challenge. Okay, so now my smartphone has parsed that challenge, calculated a response, and is now displaying the response in this QR code on the left. And you can see it has this data, and the same data is displayed in text below it. And at the very bottom of the screen here it says KGAgent detected. So the Keymaster knows that there is an agent in the middle and understands that this is the setup. Alright. Okay, so the instruction on the Keymaster side here is to show this response to the challenger. So now we're going to have to tell the agent to get the response from the user. And there it is. So now the Keymaster's job is done. As a result of this message exchange, we know the gatekeeper has established this session key. That's the original challenge that the user just signed. We know the user's public key was this 031EB thing that I just mentioned a minute ago here, this one. And we know the agent's public key. So the agent and the gatekeeper knowing each other's public key cryptographically means that they can exchange encrypted messages. So that's what's going to happen is from now on this agent is going to have an encrypted session with the gatekeeper. When I completed the login, what happened was it sent two more messages off to the server. One to determine if I'm a member, if I'm on the access control list, and it correctly said false. And another one message sent to determine whether or not this user is an administrator, and that answer came back false as well. So the messages that went across, here's the challenge, here's the response. The gatekeeper calculated the shared AES key from the Diffie-Hellman key exchange. And so now we have a AES key which is used for encryption in the session. This is a 256-bit AES key, and this cryptography is, considered strong enough for NSA top secret. So this is pretty good security. When the request for a member came across, here's the request as it came across the wire, and we can see the fields in here. So the method was do, which is generic, and it's the params which identify what the agent was requesting. So there's basically a encrypted message and a digital signature, so that the gatekeeper knows that the agent is still the same agent, and there's no substitute that can be done. So also we have the gatekeeper's temporary public key being used as the session ID, and that's the same value as we have here in the middle, so the agent knows the same session. So when it decrypted this, it came up with Here's the actual instruction nested inside the do command, request is member. And the same thing happened again when the login completed. It sent the is member, and then it sent is admin. And so far we can see those are automated. Now the thing can respond to user requests. So same user, I come along and I say get message of the day, and the same thing happened. A do went across with the encrypted parameters, result came back, and this is the value that I have hard-coded in the server side. So that's basically the demo. I could try to set the MOTD to something different, but I'm not an admin, so it won't let me. It'll just come back with an exception. This is bare bones. This is just a demo of now what we have is the capability to have a information service somewhere on the internet returning data to a browser, and then the browser can choose how to respond to that data, how to display that data. So there's no HTML going back and forth, just raw JSON data. And the access to that data can now be determined by the user's identity on the user's smartphone, held in the Keymaster client. So now we have as a way for someone with a smartphone to access a resource on the internet, and it's all done securely. The only thing which is exposed is a public key and the fact that somebody is talking. That's all that somebody could tell from looking. So that's the demo. Thanks very much for your attention, and we hope to have more for you in the future. Thank you.